Hello, everyone. In this video, we're going to continue our work in section 6.5 on improper integrals. So far in our earlier pages of this section, 2 pages back, we saw a definition of an improper integral. So you might have noticed there's a little 1 here. So this is one way that we've seen of how an improper integral comes to us. So we saw this in the pictures. It's where we have a fixed lower limit. And then the upper limit goes forever because the graph never quite touches. Okay, but there are 3 more ways that we can think about or have improper integrals. So let's look at the second way here. So we need to look at the picture that accompanies each definition to make sense of why the integral is improper. Okay, so in this situation here, for part 2, we see that A occurs at an asymptote of our graph. So we should assume this graph keeps going up, but never touches. So if we were to compute the integral from A to B, this would be considered an improper integral because there's no value of A on our graph. It never crosses like this. Okay, so how do we handle situations like this? Well, in this case, A is going to be that letter or bound that we need to take a limit of. So we actually rewrite this as follows. So I'm going to rewrite B as like a little hashtag or number symbol so that we know that B is kind of the not an issue bound. So B is fine. So we'd put that number in the upper bound still. But what we need to do is make A, or that lower bound, approach A. So we're going to let T be that lower bound, and then we're going to take the limit as that T goes to A. So this would look like the integral from T to hashtag of f of x dx. So T is just kind of floating down here. It's not a set number yet. It's just a variable. A is a fixed number. So what we're going to do is compute that integral from T to number as T approaches A. But notice T is approaching A from the positive direction. So we're going to add that positive plus symbol by the A. So visually, what's happening here is that we're taking an integral or computing the area from T to some number. And then in the limit, we're going to approach that amount that we can't quite get because our function doesn't actually cross A. All right, so that's that first or second rather type of improper integral. So now number 3, let's take a look at the graph. So here A is fine. A is some fixed amount of a number or fixed amount or a fixed number. And the bound is fine. We can evaluate our function there. But now we have an asymptote at B. So I'm going to let hashtag be A. So we know that there's no issue there with that number. So then the integral will look like the integral from that hashtag, that lower bound. I don't want to use B yet, though, because B is my problem. I can't just plug in B because my function isn't evaluated there. So I'm going to use some helper variable, let's call it T, of f of x dx. And so similar to that second definition, we need to take a limit as T approaches that fixed number B. Now notice, how does T approach B? Well, it approaches it from the left side. So we're going to use a negative symbol on the B to indicate that. So my integral is computing that fixed area. And then in the limit, we're computing that area that we can't touch by evaluating at B. Okay, so now let's look at the fourth way that we can meet an improper integral. So let's look at the picture here. So what's going on? So if we're computing an integral from A to B, and then maybe our graph has an asymptote in the middle of that bound. So how do we handle that? Well, we actually break up this integral into 2 integrals that we saw in the previous 2 definitions. So we need to treat this as one integral from A to C, and then another integral from C to B. So let's go ahead and write out what that would look like. So I'm going to use A and B here as my numbers before I use little hashtag symbols or pound signs just to help us keep track. But now that we've seen that, I'm going to use just A and B. So our first integral will go from A to T. So I'm going to let T be my helper variable that's going to approach C. And so that will be the integral from A to T of f of x dx. Then my next integral, I'll also use T here. It's okay to use the same symbol because I'm looking at different terms. I'm going to add this to the integral from T to B of f of x dx. So now what happens with T? Well, in the first integral, T has to approach C from the left side, so from the negative direction. So this I have to include a limit as T approaches C from the left. And what happens on the right side? Well, here, T is going to approach C from the positive direction. So I need to include the limit as T approaches C from the positive side. So if we get an integral that looks like this, which blows up or has an asymptote in the middle, then we need to break it up into two improper integrals like this. So just a quick note here in terms of language. So we say that an improper integral converges if all of the defining, let me highlight that while I say it, all of the defining limits exist and are finite. If any part involved in the limits are infinite or do not exist, then we say the integral diverges. So for example, in that part 4 here, all of these limits would have to exist and be finite in order for us to say that that entire integral converges. All right, awesome work going through these definitions. In the final video for this section, we'll look at example 3. Thanks for watching.